I think that should be good. Okay, let me just mess with bit rates. Yeah, I'm just messing with stream settings right now just to make sure everything's reasonable. Current bitrate, widget, should have a good connection. Okay, I think I should be fixed. Okay, so I'm probably gonna wait a few minutes. If you have any questions, feel free to ask them in the Discord, the group me, ACM discussions, or the what do you call it? Or even in the chat here. So. That's not possible. That's just stupid. Discord. Okay. So right now we have 2 people watching that aren't me. I'm gonna give it like 5 minutes, get a drink of water real quick, and then I'll be back. So stay on here, but don't leave yet. Okay, so in about a minute, once it's 17:05, I'm gonna jump in. Uh, okay, 7:05. I'm willing to jump in right now. So what I'm gonna do at this point is I'm gonna kind of walk you through the process of maybe getting started up. I'll do this real quick because I assume that you guys have some kind of text editor. My normal text editor is Vim. I've got that all configured so I can do some pretty cool things with it. But a lot of you guys don't have that, so I'm going to install. Uh, I'm going to install Visual Studio Code. Yeah, this isn't at all relevant for you. I just need to know the name of the package, which is that. So yeah, that one, and then you can see it also showed up here. This is just an installer script to install things and manage packages. Is that already installed? No. So for you guys, normally you would go here, download this, and then this tells you Debian, Ubuntu, RPM, Fedora, Linux, so like these things, you can download the one that's relevant to you if you don't have one already. Really, all you need to do is be able to type text in as it shows up. So once again, this is just running a script to download and then install it. Again, for you, you just download, you click on the thing, and then it just works. Okay. So right now I'm just doing this is just the installer. For those of you who don't know, Linux has a package manage, or pretty much every Linux distribution has some kind of package management system. And the trick is that you just type in the name of the package, install, and then it just works. I'm kind of on a weird one because I'm using Arch, so Yay's the name of the installer. There's the name of the package I want to install. -S is for sync, and so that's how you install things. Right. So while we're here, I kind of want to talk about the general strategy for the word search and why I want to pick the word search. So the word search is basically going to be like a one file program, maybe two, depending on whether or not I want to implement a certain feature. Um, right. Okay, so I got it installed, so I forgot. Yeah, it's just called code, I think. yeah. Actually, I'll go through here. Development, Visual Studio Code, and then it's just here. Okay. So, right now, I'm going to check, see if it has C support. Actually, let's open a folder. I'm going to do dev, create a folder, and I'm just going to call this. We're going to open up this folder, and I'm going to add a file. And right now, I'm just going to try to add a basic kind of setup. So I'm going to start with C++, or I'm going to start with C, because C is kind of the weird one. It's the more complicated one. And then you'll go into Python and be like, this is a lot easier. So in general, for C, you have to specify a build system, which is you specify what files you want to build, how you want to compile them, and all that kind of stuff, right? So in this case, let's see, we need, because I'll be honest, normally I have a CMake file that I copy around from scratch and it's got everything in it. Anyway, so sometime, here, I might click this. Nah, I don't want that. Okay. So the general idea here is I'm gonna add two folders, source and includes. And then let's see, how do I specify this? I do source, I do includes. Nope, not there. I add a file here called cmake list.txt. Right? What are the recommendations? Cmake tools. So this just has some debugger stuff in it. Yeah, we'll install it. Oh, no. Fine. Oh, so this is just configuring. So in this case, I just want to set what compiler I'm using. And so there are 4. This is Clang. It's a cross-platform compiler. x86 64 means 64-bit. This is the GCC 10.2. So this is the GCC compiler. This is like the Linux compiler. This one is a 32-bit cross compiler. So i686. Wait. One of these is 32-bit, one of these is 64 bits, and it's basically a GCC compiler, but it compiles things for Windows. So I'm going to pick this one. And this generates a whole bunch of stuff. Just identifies the compiler, detects the ABI info, blah, blah, blah. There. And then we got a build file thing. Okay. So I'm going to close this. Close this. No. Okay. So now we have a build directory. This is cmake install, make files, stuff like that. And so the idea is the make file tells you what files you want to build. So this cmake list is empty, so this is kind of vague. So I'm actually going to open a cmake file from Right. So the first thing, we're going to need this here. And so, first off, so this just sets out a warning. So if you try to compile something that has, if you try to use CMake on this, and you're using features that are from a later version, it'll throw an error. And so this will make sure that CMake works properly with whatever you're doing. So, in this case, right. So this is from a completely different file, but certain features in here actually require me to use version 3.13. I think it's the add libraries thing. There's one of these guys probably. We don't need it, but if you have the right, you want to put the earliest version possible that doesn't use the features that you are using. Okay, so we're at CMake minimum version here. So set CMake minimum version. Okay. And let's try looking at see if I can't find a simpler one. Get tutorials and point on a minute. Yeah, there we go. Right, so we got to set the project, in this case, project word search. This is just the name of the project. This guy here sets the include directories. And there are a bunch of little variables in here, so basically, when you want to search for a specific file in here, right, it has to know where it's going. So, real quick. So, if I type something like this, right, how does it know where to search for stdio.h? Well, there were specific files that are in there in general, right? But if I go here and I add a file, let's call this, I don't know. Right? And then if I try to do a search for it, right? Right. It might freak out because it doesn't really know where it's gonna be, so. So if we write this basic program, so this is basically hello world, but I added this registry.h thing to emphasize a point. I'm gonna go here and I'm gonna comment out this line so it doesn't happen. And so what you'll see happen is it's gonna freak out because it doesn't know where registry.h is. So in this case, let's see. Yeah, sure, why not? Well, I won't need them. So normally, sorry, this is a little easier from the terminal for me. But, right. Because the command is cmake. Cmake, where you type cmake in the directory you want everything to be built in. In this case here, this is where I want all my build stuff here. And then you type in the path to the cmake list.txt. So this means build all your stuff in the current directory, this build directory, and look for cmake cmake list.txt, one directory up. No project command is present. That's because we didn't save it. The top level cmake list.txt file must contain literal direct call to the project command, add line of code such as project name, but after cmake minimum required. So we have that. We just didn't save it. So if I do this again, configuring done, generating done, build files have been written to here. Look here, we have a make file. We can type in make, and it'll make it. Now, it didn't do anything because I didn't give it any files to make. So right now, we're going to I'm not going to do the more complicated thing. I'm just going to literally list them, but so we'll do add executable. I'm going to call this word search. And I'm going to type cmake source dir slash source slash word search.c. So this just basically says create an executable like an exe on Windows from this file. Compile all these files, glue them together, figure everything out. And this is going to give us an error. cmake to regenerate it. It's going to give us an error because no such file directory. It doesn't know where this is. Right? So we go here, and we could do this. Includes registry.h, and then this time it will compile. And then, as you can see, we have a program called word search. We can execute it using this, and it prints out hello world. Of course, this solution is kind of gross because I don't want to have to put the literal path to everything, especially if I move things around. So what we normally do is we go here, we set the include directories to be cmake sourcedir, which is again where the cmake list.txt file is. So here it is, cmake list.txt, and then in the same directory there's includes, so cmake sourcedir slash includes, cmake sourcedir slash source slash wordsearch.c. So you could see that this kind of stuff is really there. Everything else is just something that cmake generates to build things out and make sure everything works. And this is the executable. This is the make file, so this specifies commands. If you were on Windows and using a Visual Studio project, you wouldn't have a make file. You instead have a Visual Studio solution file with a bunch of projects. So it's kind of a little bit different. Anyway, we got those two bugs fixed. If we do this, then we do this. This should work because it now knows to look in this directory for registry.h. So we get this. We need to redo cmake because we changed the cmake list.txt. We need to change into build, so we're in this directory. This worked. We type in make, everything works. Okay. So this is kind of a cross-platform cmake thing. You don't need to do all this to get everything to work. If you wanted, you could literally just GCC this and then everything would work properly. Right. In fact, hold on. I want to check something. Yeah, these are all the different things you can do. You can make all of them. You can make clean, which will clean up everything. You can make force, default target, depend. All these things are different little things you can make, or they're files in the current directory. So far, I haven't configured any release or debug versions or something like that. So, Anyway. Alright, moving on. We're gonna first take an input. And the standard input for every C or C+ program, it takes in the command line arguments, or it takes in the it takes in two things. It takes in an array of arguments, and it takes in the number of arguments. So real quick, just gonna check for questions. No questions. Man, I'm either really good at this or really bad at this. Anyway, and I have to check always because I don't know if it's the I think it's argc first, but it could be argv first. I don't remember the exact specification, but there's no shame in looking something up. So gross. Proper declaration. Here's a Stack Overflow answer with a billion things in there, because that int car pointer. Right. So these are the two. Yeah, this is what happens when you get kind of systems like this, because you ask one question and then you get a billion results and you get a billion points. Kind of a mess. But anyway, moving back, it's the input. And so the standard kind of argument is so here's just a really simple program that just prints out all the arguments that listed. Puts is put. So it's put string, and if sometimes if you want to put to a file, you do f puts. If you want to put to a string, I wonder if if you want to put a character, it's put c for put character, put string, stuff like that. And we're gonna use printf. So the first thing we're gonna do I equals 0. So if you've done any Java programming, they should look similar to you because Java ripped this from C and C++. But this is a for loop. We set I equal to 0. We keep running until we end up getting we end up with this condition being false. And then we increment. So this basically, what runs before everything happens is this int I equals 0. What's checked every time you complete a for, or every time you start another iteration of the loop is what's highlighted here, and every time you finish a loop, this is what happens. So we're going to use printf as a start, just so I can like tab everything out. %s. Okay. So this is print format. If you wanted to print to a file in a formatted way, you would do fprintf. If you want to print to a string, you do sinprintf. N specifies the numbers. We're just doing printf because we're printing out to the console. So this \t is just a tab character. That's why it's highlighted a different color. This \n is a new line character. That's why it's highlighted a different color. And this %s means take. Printf is kind of a bit of a beast. If you've done Python format strings, you've seen it already. But it basically means if I had like %s, 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 something like that, then it would go, oh, let's take this argument and replace it with whatever we find here. And then the next %s would get replaced with whatever I put here. And then so this would print out each arg followed by test apple, but we just want to print these out, so. Right. So we're going to save. We don't need to run cmake again because we didn't change anything with cmakelist.txt, so we type make, we build word search, and you print out the following arguments. So test, rock, ship, apple, something like that. You can see that it prints out word search, it prints out test, it prints out whatever you give it. And notice that it tabs everything. So this is one character. It's not multiple. It's just one straight up character, and then it goes on the next line. So you can see that works. By the way, everything in this is something specific to my terminal that I made up. Yeah, so I want to test something. Because normally this is something you build in the terminal, and then you click on it, and then it sprints out answers and stuff like that. But anyway. So moving on, what I want to do is I want to start reading from a file. So what we're going to do is we're going to check to make sure that we... Oh, also, real quick. Notice that the 0th argument, argv0, is this. argv1 is this, argv2 is this, argv3, argv4. So the point of getting argc is twofold, so we can loop through arguments, and so we can also check if there are enough arguments. So if argc is less than... so let me think for a second. I think we just need the name of the file. Yeah, I have a reference here. Yeah. By the way, this would be a lot faster if you aren't doing it from scratch. Because right now, I'm literally just doing it from scratch, so it's a little bit slower. Right. So we need to check if it's less than 2, because our arguments are going to be the file name. So we're basically going to type in /word search file with word search.txt. Oh, that didn't work because that was a comma. So this is the path to it. Dot means current directory, / means here. So if I go into, I could also do this. Build /word search file with word. And this will print out everything. So that's what the // is. Anyway, do I have a terminal? Oh, sweet, I have a terminal in here. So real quick, I'm just going to close this. Yeah. Windows has CMD here, and I think you can get it set up to do Windows Subsystem for Linux. Yeah. So first thing we need to do is we need to print an error. And we could be using fputs. I think we're going to use fputs because normally printf is only if you want to print something fancy. Fputs will just put the thing on the screen. We're going to print a standard error because it's an error. So the nice thing about printing the error and outputs is you can redirect your errors to one place and you can redirect your outputs to another place. And so it's easy to separate them later. Oh yeah, sorry, remember. Yeah, I'm just gonna call it. This file. So we're just gonna print this out, and then we're gonna return an error code. So the point of this main is to return an error somewhere, and this is nice. So you can basically chain together arguments in various forms because let me see if I can think of anything. So like if I'm in the terminal, right, and I try to do something that gets me an error, then I don't want to keep doing stuff. So normally I can chain things together. So like I write this gives me an error. And what you see here is this and. It works like short-circuiting. So this is true or false or something. And then this kind of messes up so this doesn't run. On the other hand, if I do something like this, right, which is valid, WC-L just says print out the number of lines in the file. So this file has 4 lines, which 1, 2, 3, 4. Five. There are 5 lines. I don't know, maybe it's skipping something. Anyway, probably not a big deal. But like if I do this, and then I do, this will print out word count, and then it'll do ls. So it's a nice way to chain. It's a nice way to test if everything's working properly at a higher level. So basically, this part right here, if it doesn't get the arguments that it expects, it just quits. It exits and it's done. So now, right, so let's check this up. Okay, I have an earlier version of this that isn't as good, but it's still there. Yeah. Just make sure everything's all realistic. Right, so let's see, what should we focus on first? I think reading the file in is probably going to be the first thing, and all we should really do is print it out. So this stdio.h has a bunch of things for file writing, reading. So it has puts, fputs, it has fprintf, snprintf, printf, file. So we could do this. Unless I'm missing something, it might be an stdlib. It'll tell us if there's an error. So let's see. Reader, and we just want to read. Right, so once again, I don't know the syntax off the top of my head. We're going to check it up. These two sites suck. Tutorials point geeks for geeks, I hate them. This one's pretty good, I think. This one's really good. Yeah, this one's perfectly fine. This one actually has a lot of good stuff. So yeah, oh no, I actually need to. No, oh, so I got the syntax wrong. So normally you pass in the file name and then you pass in the mode. So do you want to read it for read only? Do you want to write to it? Do you want to append to it? Do you want to update it and read and write? Do you want to update, read and write? Do you want to append and update? So my bad. So right now I'm going to do open argv1, and we want to read. Okay, so now this is a very important thing you have to do. Every time you do fopen, right, or anytime you do anything with possible memory, you gotta do fclose. Right. And then it could also just not work. So if it can't read the file for any reason, say the file doesn't exist, right? So so if reader equals null, that's what happens when it doesn't exist. It just sets it to be null. Then so we're going to just print out an error that says file does not exist. And we're going to return. So 0 means everything works properly, anything else means it didn't. And in this case, we don't need to close it because it was never opened successfully. So if we called fclose, it would just see that it's null and just do nothing. Right. Sorry, I have my voice on a little bit of delay here, just to kind of mess with my head. So, and just to make sure that I can be heard, so. Okay. Right. So the next thing I'm looking at is how I handled certain things. Right. So I didn't do a null check, that's fine, whatever. Actually, hold on. Let me try to mess up something. So what we're gonna do is, I wonder what happens if we try to do reader. I'll explain this in a second. I just need to get it out there. I'm gonna try to create a segmentation fault. No, I might as use fputs because it's a little simple. By the way, if anyone has any questions, now would probably be a good time because I'm just messing around. So I'm actually not gonna have this, and see if this works. Yeah. So in a lot of operating systems, if you type in Alt Shift, it'll highlight multiple lines at once. And then so I can do this and just comment out all four of these at once. If I wanted to, I can highlight, delete them, I can mess around with stuff. Let's try compiling this. I just want to see what happens. Whoops. Go into here. Yeah. Okay. So, missing a semicolon, as you can see here. And it's giving me a bunch of errors. Warning. Probably got the fputs backwards. So that's definitely a problem. Yeah, okay. So I've been writing it the other way. So it takes in the string first, and then it takes in the file thing. So we're just gonna fix that real quick. That is a huge error. That'd probably give us a thing. And then So that's what it is, incompatible pointer type. Expected const char pointer restrict, but argument is of type file pointer. So it's looking at this, it's telling you what it expects, int f puts, so int, what does f puts return? I don't remember what f puts returns, but it's looking at this, it's saying, oh, it needs to be a const char pointer, and this needs to be a file, but I've passed in a const char pointer in a file. By the way, a const char pointer is basically a pointer to a character that you can't modify. But because of the way C and C and kind of C++ works, is that when you point to one character and you give it to any function, right? Normally they keep reading until they find the magical null character, which is automatically applied to every single one of these. It's basically 0 in ASCII. So anyway, this should fix both those errors. You can see here, or these are warnings, but they're future errors. Warning, 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 warning. Error, expected semicolon before return, so it needs a semicolon here on line 13. So you can see it. Anyway, we make it. If we run word search now, hello world. Oh, sorry, I need to remove this hello world. But you can see it tells you missing file name, syntax is //that-file. So now I'm not doing proper stuff that I should be doing. So there's no file name test here. So if I type test, yeah, we get a segmentation fault. Okay. Let me see if I can draw the picture, because segmentation faults aren't as weird as you might expect. Sure. Oh. Okay. A segmentation fault is basically so here's the basic idea of how you guys. Let me see if I remember. I wonder if this is just a straight up rectangle. Pencil. Yeah, well, I'm just gonna draw shapes. Shapes, opacity. Sorry, I was using some game dev thing. So whenever you request a memory from the computer, right, it basically gives you a box. Though. Oh, that's just an optical illusion. Okay, it basically just gives you a box of, say, like 4 kilobytes, right? So we go here, right? And so every time you ask for memory for any program, it gives you about 4 kilobytes. Now I'll just leave that. Tools, let's do this guy. So then, now it can vary from system to system. Sorry, it's just. Man. For some reason, it's being weird about floating selections. And I didn't merge these 2 layers. So, there, this should work. So, anyway. So, you go here, and you want 8 kilobytes of memory, right? Or maybe, let's say you want 10 kilobytes, right? So what you're computer will do is it'll get you a bunch of 4-byte chunks. Right, and say, here you go, here's 12 bytes or 12 kilobytes of RAM because we have to do everything in 4 kilobytes. Now, once again, it could change from computer to computer, operating system to operating system. Okay, so, and then you basically fill this in with whatever memory you're using, right? So whether it's dynamic or stuff, whatever. So then, now the next time you ask for like a kilobyte, right, what it'll do next is it'll actually say, okay, so now you want 11 kilobytes. Well, you're already using 4 kilobyte chunks of memory, and you got 2 kilobytes left, so I'm going to give you one of those. Right? So that's normally how it works. And so, here's a quick question for you. Say I have something around here at the end of the 4 kilobyte range. I've allocated 12 kilobytes, right? And then I just start modifying, say, I go by memory address and I modify something like 2,000 bytes later from where I currently am. So, real quick, let me just draw another one. So right here, this is all your memory, right? This is the memory that you own. So this is all your memory, but if I go here, we go over here, and this is Google Chrome's memory, right? Now, of course, this being Google Chrome means that there are like hundreds of these all over. But because memory is laid out sequentially, what you can do is you can go in here, you can modify something over here. So I could say, I don't know, let's say that this is address. So let's say this is address 1000. This is address 1000 plus 4 kilobytes. So right. And so this happens at memory address 1000 is where it starts. This is 1000 plus 4 kilobytes. And this is 1000 plus 8 kilobytes, right? Okay. And say this is address 1000 plus 12 kilobytes. Okay. So basically, if you want to modify something within the first 4 kilobytes, yeah, normally you don't care about these boundaries. So you would say, hey, just get me wherever this memory address starts, right, plus 1,000 or plus 2,000 or plus 10,000. So you'd modify something over here. But because you can do certain things, you could try modifying stuff that's way outside here. So you could say, hey, give me wherever this memory address is plus 12 kilobytes, and then you'd start modifying this one, or 13 kilobytes, or you start modifying this one. And so you'd end up modifying memory that you shouldn't be memorying. You'd end up modifying memory of other processes. And that's really bad. So that's what a segmentation fault is. So, let me see. Real quick, I'm just going to check this, because normally I go hard on it. Okay. Yeah, you specified this variable. So I don't know what I specified by default. But what we could do is we can actually debug this. Oops. So we're going to do the cmake dot dot, but then we're going to add a D for define. Right? And then cmake build type equals debug. Then we do a make. Okay. So I think this already built the debug version. So what we can do is okay, so this program called GDB. It stands for new debugger. The compiler is G, new compiler collection. Everything that starts with the G starts for new, which is a whole thing. Turn. We're gonna run right. So as you can see, I ran it. Program received SIGSEV segmentation fault. What does that mean? Well, as I said, we can hit backtrace to see where the segmentation fault happened. So you could see it happened at line 12. Right. Okay, so this is actually a little trick here, because sometimes it's a little inaccurate. No, I remember why. It's because... So, no, it did happen line 12. It happened line 12, we just had puts hello world, but I removed it, so line 11. Anyway, if we type in... BT stands for backtrace. It's basically like if you've ever seen a Java error where it like prints out everything, or a C# error, this is the equivalent version. So let's go to frame 2. We can see the line here that caused the problem. We can print out info locals. And you can see that reader is null, right? So you see this test down here, if reader equals null. This is what we're testing for. Because there's a special like 4 kiloblock section of memory way away from what everyone else has. That's called null. So there's a 4 kilobyte here, 4 kilobyte. So in fact, right now, let's do something. We can actually print the address of the test variable. Yeah. So right now, test, instead of the memory address being something like 1,000, it's whatever this is. Right, so... Oh, cool. This is useful. Right, so anyway, it's basically... What's that? 1, 2... So that's 1,000, million, billion, trillion. So it's 140 trillion, 737, 488, 348, 092. That's kind of that's the space that we're in right now. And right now, we're trying to access something that's like way away, right? It's all the way at 0. That's not a block that we have permission to access. And while I'm at it, right? And you can see that these guys are right next to each other. So like, in fact, yeah, so they're literally 4 bytes away from each other. So if you were to look at your memory, right, you would have basically this int, and then 4 bytes later, you would have this reader. Anyway, and this reader refers to the variable. So the memory address of the variable is stored here, but it itself stores a memory address. Anyway, so the problem is that we're basically trying to read a block that we don't have. That's what causes the segmentation fault. To fix that, we either have to prevent that from happening in general, Alt-Shift to highlight multiple, and then shift to do that. So what I'm gonna do actually, hold on. I think if I do Alt Shift and then Alt, no, that just moves the first line. So Alt and then up or down moves one of the lines. So I'm just gonna copy and paste. Right. So now if we do this and we run this program, we'll have actually handled errors properly. Well, we have to compile it. Again, I keep mixing up the order. I don't know why. I think fprintf has the other order. Anyway, yeah, fprintf has the file first, then the format string. Anyway, so we fix that error, we make boom, right? We can run it and it works. File does not exist. In fact, let's be a little bit better about this. We're gonna do fprintf. Okay. So what this will do is it'll print out file, this tick mark, and then it'll print out the name of the file, that this RV1, which is just this guy, and then say does not exist. So we save this, we make this, we run it. File test does not exist. By the way, because I'm in Linux world, none of these I don't need file endings for anything. So I don't need like .exe, I can just do file. Okay. So yeah, I'm just checking for any questions that popped up. I kind of got in a little bit of a flow state, so if that happened. No questions. All right. Again, must be either doing really good or really bad. So right now, we just did some error checking. File doesn't exist. It returns if it doesn't see anything, and we're all good. So yeah, in fact, while I'm here, why don't I actually make a basic sample word search file? Because I think I have one. Yeah, I have one on my other computer. I cannot use that one. That one just has a bunch of very inappropriate words. What about size test? What's size test? Man. Yeah, no, so I don't have one. So actually, let's just generate a word search. No, I need it to be text. What did I use? Okay, so computer science programming language Linux Windows Mac OS macros include printf puts fprintf std out std air let's see here. Level, intermediate, letter case style, uppercase, alphabetized word list, sure. Let's see if I can add some other ones. Error. Oh. Pointer. Okay, so I think that should be good. Come on. Yes, it's text. Okay. So real quick, I'm just going to create another file. I don't want to put in build. So maybe let's make another folder and let's just call this like, let's call this, nope, I do not want it there. So here's build. I swear. All right, it wants to fight. There. And let's create a new file, and I'm just gonna call this oh my god, it didn't do any new lines. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Okay. It's fine. It's fine. Let's see. Yeah, someone's already had this problem. Okay, so this is real quick, we're just gonna save this and I believe it's every 18, so. Okay, so this is sed, it stands for stream editor. -E is like extended or something. So this means substitute, dot means, the slash means separates arguments, so everything in here is one argument, everything in here is another argument, and this is like some extra info. So basically, substitute, dot is any character, backslash curly brace means interpret this next thing as a number of characters, 18, and the backslash, so this means substitute every 18 characters with ampersand means whatever you found here, followed by a new line. And this redirects word search into here. Yep, it's 18 characters. So we can just copy and paste this. Control A, backspace, Control V. Okay, so here's our word search. And one more thing I'm going to do to make it a little easier on myself. The first line is going to be 18. Next line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 18 by 12. How many words did I add? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 17 words. And you'll see why this in a second, because in C you basically have to allocate things manually. So it can kind of become a bit of a problem if you're not careful. Man, they just really love fighting me. That's fine. Printf and fprintf was probably not good to add. Science, stdr, std out. Windows, okay. So, we're doing this because we really want to make sure that everything kind of works properly. Everything fits in where it needs to be. Right. How would I describe it? Because basically, what we're going to need is we're going to need the computer to tell us, hey, you need to allocate an array that's 18 by 12 to store all these things, right? And then you're going to need to allocate another array of 17 strings to store all these guys. And real quick, I'm gonna add this just to, first off, I'm gonna get rid of the hello world because we don't need it anymore because it was just there. So all we've done really is just take in arguments, make sure that we can open the file, and we're actually gonna do a little bit more. Right. Okay. Change all occurrences. We're gonna make this num rows. Okay, so the first one's gonna be the rows, right? No, it's gonna be the columns. Oh, in that case, I'll switch it up. 12 by 18. So it's gonna be the num rows. We're gonna have another one that's num calls. We're gonna set that equal -1. Num. By the way, if anyone's wondering, there is a shortcut. I could have done this because of how C++ works. I think something like this. But I'm not going to because it doesn't add anything. And then let's do length. So this is just to make sure that we don't overstep anything. Oh, okay. Sorry, some bad. I just realized some bad. So this is part of the reason why C is a little hard. It's because if you look closely, we open this file, and if we can't read this is the decimal number %d from the reader, and put it in num rows. If I couldn't read any characters, that's an error. But anyway, so you'll notice that I actually need to do like an F close in here. Real quick, I just want to check something. Source. Right. So I'm just checking because I don't know if I properly handled it. So the kind of there are a few ways to do it. One of them is just fclose wherever it shows up, but for dynamic allocations, it'll get annoying, and so we're gonna end up using goto, and it's gonna I know it's like goto considered harmful. There's a famous article. Goto statement considered harmful. We'll go to the Wikipedia. And it's basically, how would I put it? Yeah, and everyone wants like snow clones, like parodies of it and stuff, like considered harmful, essays considered harmful, blah blah blah. But anyway, the problem is basically the goto statement can lead to really bad spaghetti code. But we're gonna end up doing it in a very structured way, so we shouldn't see any problems here. And in like modern programming languages, normally you can get around the whole thing anyway, and you don't need to deal with any of this nonsense. So yeah. Yeah. So what I'm actually gonna do is I'm just gonna do I'm gonna do this, and I'm actually going to kind of implement it. So instead of returning here, it's one, and then we're just gonna do a go to. Something like that. I don't normally use goto, so I don't normally go straight into C, but okay. Let me just make sure I'm using gross, gross, gross. Yeah. So here we go. C has resource acquisition is initialization, do it more idiomatically. So then if this doesn't work, you go to here. If this doesn't work, you go to here. If this doesn't work, you go to here. So basically, every time there's something wrong, you clean things up. Um, and this is standard in the Linux kernel, the Windows drivers, stuff like that. You can also break out of nested loops with a goto, or you can like normally set a variable or something. Stuff's device uses switch cases, but yeah. So just you have to be very careful with it, but in this case it'll be fine. In fact, I might even do this just so it's there. Kind of break indentation rules. But anyway, so the idea is if we've successfully run this, right, and say we get an error somewhere else, we could do a bit more. Let me see this. I think this will work. And then solving a D. So yeah, in this case, we're going to do num rows, num calls. And we're going to do a new line. Clean up after ourselves. Okay, so blah blah blah, print this out. We need to make sure that we also get the num rows and num calls. And then I need to check to make sure, because I think fscanf. Not this one, not this one. This one's the good one. Or there were two good ones. So the output, the number of items the argument list successfully filled. So in this case, we want to check. So if it was able to fill less than 2 arguments, then we're just done. Yeah. So yeah, I think this is good. We're going to try, we're just going to run make again, see what happens. We're going to go back into build, see what happens. Const card pointer, but argument is type restrict. Oh, yeah, no. Sorry, this needs to be printf because we're printing the standard out. If we did fprintf, we'd have to provide standard out as the first argument. So anyway, we go here, we save, we fix this, it works. Word search, we need to go into example, see word search, solving a 12 by 18 word search. So you see this reads it properly. It'll handle closing files and stuff like that. Okay. In fact, let me just do this so it's clear. Anyway, so now that we know the size of the word search, what we're going to do is we're going to allocate an array of characters. Checking, see who's there. Any questions? Gonna check the Discord. Group me. Nothing. Okay. Once again, I mean, they're really good. Okay, so in C++, you would use new. In this case, we're going to use malloc, but what we're going to do is actually going to be a little bit weird. So actually, the first thing we got to do is we got to set the word length. Does this have... Hold on. I know I don't need it, but... Yeah, I might as well. Because I'm gonna need... Okay, so in this case, we're gonna do... So the max word length is gonna be equal to the max of num rows and num calls. Okay. And that's something we might take care of later, but it's just something I remembered, so we might as well take care of it now. Okay. So we got max word length. So now we're gonna need to allocate space for the array. So we got those, we got the max word length. Ooh, looks like I did something fun. Okay, so I'm doing some hashing stuff here. Yeah, this is probably going to be another example of things that took a little bit longer than I intended, but it'll probably work out. Sorry, I just looked at the old stuff I did. Let's see here. Right, yeah. Okay, so I think I want to be a little smart about this. So what I'm actually going to do is do a car pointer, and this will just be a word search. Yeah. The worst part about this is actually an earlier example. The code I'm basing off of was an earlier example before I made that fix. So let's see here. Free all items, blah blah. Consume new line. So it is alpha. Yeah, I think I didn't code this in the necessarily best sense, if I'm being honest. No. Okay, so I see what I'm doing. Because with the plus twos, basically, the idea was that if you have a word search like this, so if you have something like this, it could make your searching algorithm possibly a little easier if you added like dummy characters, like so you see this, so basically I can keep searching in a direction until I hit like the wall, right? And then at this point I know I've reached the end. And I could do this instead of checking if I'm going around here. It's a similar logic to how C does strings. But I think I'm going to keep it a little simpler. I'm going to keep it a little simpler, and I'm just going to allocate memory for this. Okay. So I want you to notice a few things. First off, this malloc allocates the number of bytes you give it. So size of car gives you basically how many bytes a character takes up, which is normally 1 byte. Num rows is how many rows we have, and num columns is how many columns we have, right? So, and then we store it in a pointer to a character, because once again, we're going to access this array. But there's always a rule that you have to follow, that whenever you malloc something, whenever you dynamically allocate something, you always delete it. So, in this case, uh, okay, so here I am deleting it, right? So if I get an error after this point, I'm going to jump to here, because then this will handle cleaning it up, the word search, and it'll handle closing the file. In fact, I might even just a little bit of space there. And you delete with free. Sorry, the first thing I gotta do is I gotta allocate. Let's see if I did anything else weird. Alright, so I had direction array, but I don't need it. Actually, that might make things a little simpler. What was the point of this? That just looks like I could loop through and check. Man, this looks like a really crappy implementation of it. And pointer list size back. Okay, so the next kind of thing I'm thinking of is I want to make a bunch of hashes for the characters. Alex. Okay, I think I see it. Yeah, so the idea is to make it simpler on myself. What I do, instead of like checking here and then checking diagonally and stuff, I would say, okay, I'm looking for the word computer, right? So what I did was I cached every single location of the letter C. So here we could see a C, here we could see a C, here we could see a C. There's computer, right? So I could start there. I'm not just looking around randomly because that's a really bad algorithm. So let me just look up. Because I'm pretty sure if I just add a space. Read two non-white space characters, skipping any white space before each. Right, so okay. Anyway, we got this. We got the cleanup word search. Okay. We've memory allocated this. So now what we're going to do is we get our locations. Okay, I'm starting to come back to me. Right, so okay, here's the idea. Right. The first thing we gotta do is we gotta get the word search into memory somehow, and this we've allocated space for it on line 26 here. Right, so the first thing we need to do is okay. Reader. Okay, sorry for going silent for a second. I basically just needed to straight up focus really hard. IJ. Okay. I say really hard, but it was basically just me going back through old code. So, right here, we allocate memory for the word search, right? And then we're just cycling through the word search. We're reading from the file the character and storing it in word search I plus dump columns J. You might alternatively see this as okay. So basically, what this translates to is get me the Uh, okay, so first off, I'm storing this as a 2D array as a 1D array. So to get the ijth element of this 2D array, you multiply I by the number of columns and j by the number of rows. So, for example, if we have A, B, C, D, F, G, H. Okay, so for example, this is the 2D array, right? How I'm storing it. That's the conceptual representation, but how I'm representing it in memory is this. Something like that, right? So if I want the second row, third element, that'd be this G. So it'd be 1, 2, 3, 4, 5, 6, 7. So I need to get 7. So I do that by adding 4, the number of columns, times the number of rows I want to go down. So I would want to go down 0 to get to B. I'd want to go down 1 to get to here. I'd want to go down 2 to get to here. Array start 0 kind of idea. And so I want to jump down to here. So in this case, it's I times the number of columns plus j. So we could look at this. Don't. None of these are good. So the other way to do it is you could also have like a pointer to a pointer, but then you need to allocate for every single row, and then you need to deallocate and stuff like that, and it just becomes more of a mess. So you look at this 2D arrays, 1D array. Width times row plus column equals value is how you set that element. So I'm actually gonna, I don't want to do everything in main, so I'm actually gonna create a function up here that just we're gonna do this. Okay, so here. By the way, while I'm here, if you have an array in C, this is equivalent to real quick, sorry. Okay, so it should be a little bit brighter for you guys. Array, accessing the X array with this is just a shortcut for add X to the array and then dereference it, so get what the value actually is. So that leads to something like this actually being valid code. Right? Because it's just a memory address, right? So I'm actually going to probably step through memory as I do this, but anyway, moving on. So what this does is it fscanf, if it sees a blank space in there, it'll basically ignore all white space until it gets that. So this is going to ignore all white space until it gets the next character that's not white space. Unless... Let me check to make sure. Let's see. Oh well. We'll find the error when it comes up. Anyway, word search this equals 0. Improper format, I'm trying to read this element, go to cleanup word search. Okay, so this basically will just put all the characters from the file into the word search in a format that's easily indexable. Next thing we're gonna do, we're gonna zero out I'll be honest, I'm just gonna skip this because it's actually just shorter to write the word search thing and it's less info, so I'll leave it like this. Okay. Okay, so here's a interesting fact about ASCII characters, right? And I'm assuming ASCII for this pretty hard because I don't want to deal with locales and stuff. But if you actually look at the ASCII table, so you look at A, right? It's 65. Capital A is 65. Lowercase a is 97. And 66 is here, and here, and here, and you can see them kind of all working together. So if I try to print out the A character as an integer, right? Let's see if we can put this out. If we look at the bits, it'll become a little bit clearer. Okay, so A is basically 0, 1, 0, 0, 0, 0, 0, 1, right? It's 65. So this is 64th bit here, and then it just goes the way you'd expect. But uppercase A, or lowercase a, is exactly the same as A, except the 1, 2, 4, 8, 16, 32nd bit. So the 32 bit is set. So what I'm doing with this next line is basically saying, hey, take whatever's in here and it, bitwise and it, with this value, which is basically, oh, hold on. So, as you can see, bitwise and, if I do A and B, right, so this lets me set the individual bit, and it's going to let me set the bit to 0. If I wanted to set it to 1, I would do or 32. So, for example, if I get a lowercase a, that's going to be 0, 1, 1, 0, 0, 0, 0, 1, right? And then if I and it with not 32, that's going to be 1, 0, 1, 1, 1, 1, 1, 1. So then the result is going to be, well, 0 and with 1 is going to be 0. 0 and with 1 is going to be 0. Wait. Oh, I'm sorry. I'm off by 1. So it should be, sorry, it should be here. So it's going to be here, right? 1, 2, 4, 8, 16, 32. So this is going to be 0. This is going to be 1. This is going to be 0, 0, 0, 0, 0, 1. And if you look at what this number is, this is 1, 0, 0, 1, a bunch of zeros and 1. This is A, right? So this basically just says set this to be lowercase, or set this to be uppercase ASCII. And this is just to cover ourselves in case anything weird happens. Actually, hold on. I can... Let me save some typing here, because I end up typing this exact same phrase a lot. So what I'm going to do is I'm going to do... So this is just going to be the memory address of this. And in general, always prefer using more variable names. Kirkar. Is alpha. Okay, and where am I getting out is alpha from? I think is alpha should be a standard C program. Skip this one, go to c++.com or CPP reference. Everything else sucks. I don't know why this one's taking forever to load, but this one's good. Right. So there could be like some weird stuff going on here with this, but it says in the CC type thing, but yeah. So generally, if it's a C function in C++, so if I wanted to use fputs and I was in C++, I would do include cstdio, right? So in this case, it's telling us if you were using C++, it's include C type, right? CC type. So what you do is you take off the C in the front, C being that's from the C program, and you add an H at the end. Okay. So this checks if it's not a letter, then we skip it. Yeah, and if we don't get something that's an alphabet character, we're just going to print to error. So this will get the print the current character. IJ. And then word search. Okay, so what I'm going to do here is I'm actually going to introduce a struct. And a struct is basically just how you group together data in C. You don't have classes or anything, but it's like a class that just has datas. So I'm going to call these locations. And this was actually something that they needed to get the Linux file system working. The Unix file system. They straight up could not get it working without introducing structs. It just was too much of a mess. So in this case, list int size pointer back. Okay, so conceptually what's going on here is that size is the number, um, and you kind of gotta think a little bit ahead, but it's like weird. You gotta know where you want to end up before you can get it. So what we're gonna do is, okay. So if you see this line, we're basically going to allocate 26 of these in this variable called character hash. And the idea being that if we want that this is going to store all the locations which that character shows up. It's going to have a size so we know how many characters or how many locations there are with those characters. It's going to have a pointer so we know where all those characters are. It's going to have an array so we know all the characters are. And it's going to have this back function, and this is going to be useful later when we add to it. So in fact, so we know like where to add to it at the end. I'm gonna check one thing, because I wonder if there's a thing called zero adding a struct, and I want to make sure that it's always going to be zeroed out. So modern C, yeah, compiler dependence not good. Full. Yeah, I can just manually set everything to be 0. Technically, I should be able to do this, but I don't. I'd rather not. I think I just want to do memset. That's C++. Ooh, stop memsetting structures. Let's check that out. Kernel leak. So yeah, I think the simplest solution is probably just gonna be okay, less than 26 I plus plus. So we're just gonna loop through, and we're gonna set character hash I dot size equals 0. We're just gonna set everything to 0. Okay, and because we allocated this on the stack, we didn't use malloc, it should be fine. Okay. Let's... Right. Let me see if I can't print this out. Yeah, so right now, I'm just going to print out the things just so we could check it out. Because I've gone quite a while without actually implementing anything, and so that's going to be... plus. we're just going to use put C. I'm just going to copy and paste this here. Except I don't need this. And I can do this furthermore. And then, so this just puts a character on the screen. Okay, now I want to test this, make sure everything works. So we're going to make compiler error, implicit declaration of function max, error too few arguments to function put C, implicit declaration of f printf. Make again. F pretend F. Okay, that's where the T went. Okay, max implicit declaration. That's not good. Put C. What the hell does put C need for? Oh, I need to specify the stream. Gross. That's fine. STD out. STD out. Undefined reference to max. Okay, so as you can see, it built it properly. And max is almost there, but it couldn't find a reference to max. And that means that basically no one ever defined this max function. Which is annoying because it should be defined. So we were able to compile all the individual files. It's just that one of them just didn't work. Best way. Macros are gross. Well, at least in this case. You know what? I know what I need to do. Max is just kind of a little bit shortcut, but it's fine. So. So basically, the idea being that if I have this word search, right, I can't have any word that's longer than 12 characters because it would go off the side, right? So I'm just assuming that everything fits within the minimum thing. So all this does is find the min, and also that code was wrong because it should do this. Okay, so we're gonna save. This one's gonna work because we don't have that. Control R, word search, and if you look at that, it's 12 by 18 word search. It prints out everything we need, right? So it's pretty clear what's going on there. It's exactly as you would expect. Anyway, so we got this. We're printing it out on a new line. It prints out the word search. So we are, in fact, getting the word search. Okay, so now we need to. We haven't gone through the whole thing. We've only gotten here, but luckily the next part's going to be pretty simple. And this is why we need max word length. So what we're going to do is we're going to create wonder what I called this. Actually, we need to do the character scan thing first. So I'll leave that for a second. Anyway, here's us printing it out. Uh, in fact, let me see if I can't do a little bit of refactoring here. A lot of these are error handling, which is kind of annoying, but yeah, whatever. Well, the only thing I could refactor at this point is this, but I need to return an error, and then if I get that error, I'd pull it out. But anyway, again, in general, long functions are really bad, and this is already kind of long, but I might just kind of refactor it later, depending on how long it takes. Again, gonna check for questions. No questions, it looks like. Man, I hope I'm not getting really badly delayed. Oh. Okay. Right. Really hoping someone can see this. Okay. Yeah, no, it's kind of gross. If the audio works, then the audio works, but other than that. Anyway. So I'm just gonna move on. So what we're gonna do is we're gonna loop through, and we're gonna add enough memory for all the locations that everything showed up in. And we do that by character hash I dot size plus plus. Okay, so basically, not I. We need character. Right. So what this will do is it'll say, "Hey, we found the character, whatever character we found here. We're gonna subtract a, so that gets it to a number from 0 to 25. So it's gonna be a number, right, in the array, and then." Just to make it extra clear, because there's always the chance that the operators don't work the way you think they do. So it's going to deallocate it, it's going to get the number, it's going to subtract off this, so it's going to be somewhere in the array, and it's going to say, hey, we found another copy of this letter. And then we can use that to do this. 0 I is less than character here. No, I is less than 26, I plus plus. Actually, no, this should definitely be its own function, because otherwise it's just gross. So first off, we're gonna do and we're gonna take in I wonder if I could specify 26. I wonder if I can specify this. I could if I wrapped it in a struct, but I'm not going. I'm just gonna keep it just in case it catches it. 26 I plus plus. And just to let's do a pointer to this. Yeah, let's try this. So I'm giving this a different name just to emphasize that it's not a thing. Okay. So I'm gonna dereference it first, and I'm gonna access the ith element, and then I'm going to get list, and I'm gonna free it. And then I'm gonna do I'll be honest, it's kind of weird doing these videos sometimes because I don't know exactly how much people know. So I'm either going way too in depth or I'm not going in depth enough, and it's just kind of gross. But yeah, anyway, malloc. Um, I don't remember if C has that operator. But yeah, I was thinking there's this operator for if pointer to something that I could use sometimes, but I don't think it's gonna work. Anyway. And then actually, let's do this so it's a little bit easier. Okay, so yeah. So if the current allocation failed, we're gonna return. Nah, alright, we're gonna return run. Return 0, else we're gonna return 1. Just go have to read it. In fact, let's just do this. Let's make this also a function, because there's too much in the main function. Okay, we're gonna need car pointer word search. So we're just gonna drop this in here, and this should work. Okay, this probably won't throw. This doesn't throw any errors, so we're fine with this. Or even if it does, who cares? And then we're actually gonna put this stuff up here. here. Gonna put these down here. I'm kind of glad I didn't do the physics engine. That'd be a little much. So basically, in C, you gotta know about the function existing before it happens, or else it's gonna get weird and it won't know what to do. So I declare it up here, so it says, okay, when I see these functions, don't freak out. And then down here, it's like, oh, here are these functions. So when it links everything together, glues everything together, it figures out, oh, I need to put this here and this here, right? Oh, and this applies to C++ too. Yeah, let me really cover my ass here with... Can I set defaults in structs? No, you can do it in C though. You know what? I'm just gonna, just to really make sure everything works properly, I'm gonna do one better. Okay, I think this should work. Because it's gonna read this as like this, and then figure it out. I'm just gonna try running it, see what happens. Locations, unknown type locations, unknown type locations. Too few arguments to print word search. Because print word search needs num rows and num columns. That should fix one of these errors. Locations needs to change to locations. And then I think I need to do this actually. Yeah, and see, you need to specify struct in front of like every single one, unless you do some weird stuff with type defs, and I'm not. There's like a type def this, but like I might as well. It's kind of like the standard, so I'm not gonna rock that boat. Expected this before car hash. Expected this token, so I'm just missing something. I'm gonna do this. And then we're just gonna I should be fine. I think I was freaking out about providing a pointer to something, but okay, let's check it, see what make does. Same error. We're just gonna fix that in a second. make subscripted value is neither pointer nor vector. That's a different error. That's cool. This one's freaking out because of course it is. It's not. Okay. Make expected expression before this token. Yeah, this is the strat. I might actually do this. Yeah. Yeah, I think this would probably work. Null, 0, null. We're going to try that. We're going to back that out. We're going to try running it, see what happens. Nope. Got mad at us. Why? Oh, hold on. So 0 is then 26 plus plus. Yeah. Let's see what this does. Okay, so that worked. And it prints out the word search. All good. Let's try inserting a bad character into here. So let's try 5. If we rerun it, element, it can't read it properly. That's not great. Oh, no, it's because... Sorry, it's because if I look at 7... no, it's because we changed it. It gets the right location. Row 7... 1, 2, 3, 4, 5, 6, 7, 8. So it gets the right location. We could do a little bit more error handling here. I need to be doing this is alpha check before. That's the secret. So we save. We save. We make element 5 at word search. And let's be a little bit nicer about it. We add the tick marks so they know what character. There we go. So that should all be good. And the nice thing about this is it can like autocorrect, so lowercase letters, so you can throw lowercase letters in there and it'll figure it out. So for example, we go down here and you see this T is uppercase even though it was saved as lowercase, and that helps with searching algorithms because we don't need to consider any other nonsense. Okay, so we print the word search. We need to allocate character hash. So if we were unable to allocate the character hash, we're still gonna free it. Or actually, no, we're gonna hash, we're gonna do free character hash. Because what's gonna happen is that this is an array of things, and at some point it failed, and if it fails, it's just gonna like clear this guy up. Right, so even if it fails like halfway through, it'll still clean up the earlier ones, and it won't do anything because, well, it set them all to null. So freeing null never screws you over. So if we were unable to do it, we're just gonna go to we need to print an error. Fputs always does it backwards, so we're just gonna try this, cannot allocate this, and we're gonna do std error. We should pretty much never see this error. We're probably never going to see this error because the only way it fails is if I use up all the RAM on my system. And really hope I'm not counted as a concurrent viewer. It's something that could come up. The error is something that could come up to bite you, but it's probably not going to happen. Normally, if you can check to make sure it works, and it just works. If you ever get this error, there are probably bigger problems, and this you're just gonna have to restart your computer anyway. So anyway, so we've allocated that. We print out the word search. We're gonna do this. We've set the number of columns. Right. Okay, so let's see if I can expand its color. So all this does is it basically just figures out how much space it needs to allocate in the word search by figuring out how many times the letters show up, and then once a letter shows up, it starts in here, right, and then adds this guy in, and stuff like that. I remember how the up, down, left, right search worked anyway. So, and this is why I added the buffer. So basically, there's if you remember me talking about adding the dummy characters around the word search, so it's like add A B B C D E at. It's because the original way I did it, I just searched in this direction and kind of kept going. But if you had the word like on one end and then like down the other one, it would catch it. So yeah, that's not too hard to fix actually. So what I'm going to do is I'm actually going to go ahead and fix that. Okay. So I'm just going to allocate those guys. Malloc doesn't set things to 0 actually, I think. It's actually calloc. So we can use calloc instead. No, gross. I don't want to talk to these guys. So calloc initializes all the bytes to 0, but malloc just gets you the memory and doesn't do any kind of checking. So right. Anyway, so yeah, let's do calloc. Allocates zero's memory. Okay. Size t num, size t size. Size t is basically an unsigned type, and it's kind of the largest size you can use for any container. So in this case, we're gonna do this, comma this. Number type. This is size of each object. To avoid memory leak, you must free or realloc. We won't need to use realloc, but the idea is if you have like a data structure and you want it to be twice as large, so you say you have a list and you add to the very end of it and you keep going, eventually you're going to reach a breaking point. So to get around it, you kind of reallocate the memory, and that'll figure something out for you. Anyway, so numeral. So this is going to zero it out. And when it zeroes it out, it sets it to the null terminator, which, if we go back to our ASCII table, keep that, keep that, keep that, keep that, keep that. Anyway, now I'm looking for ASCII table. So if you see this, it has decimal value 0, it's null, and so here's kind of the main idea behind like C strings and everything. When you get a memory address, you normally you can allocate bytes of memory in contiguous chunks, and then you can keep allocating, or you can allocate bytes of memory in contiguous chunks, and then you keep reading until you reach an upper limit, or you keep reading until you reach some character that tells you to stop. So, for example, with strings, it's normally to go until you see the null character. With C plus, or with like arrays of integers and stuff, you normally go until you reach the end of the row or whatever. The end of the array. So we're setting these to be the null character, and since we can't read in the null character because we're not reading binary mode, and even if you have a null character, it'll kind of mess things up. Since we're not reading the null character, we're not going to deal with it at all. And so we could set this to be 0, so it's going to, if it reaches the end, it's going to hit 0. Okay. And to get around that, we're going to do this. Numcalls plus 2. Do I add 2 to the numcalls? Because that'd be something I do. Nope. And you can kind of see why you don't copy and paste, because sometimes you end up with and we're gonna actually, yeah, again, kind of gross. This one's fine, this one's fine. So this should still work. If it doesn't, you know, that's obviously a problem. Yeah, so that's obvious. That's a little bit of a problem. BMS. Okay, so here's what I'm gonna do. I'm actually gonna make this function I said earlier was gonna be useless, but In fact, let's just make it a struct. And this is gonna have a car pointer called word search. It's gonna have int. So yeah, you can see why having this would be very important to do. So anyway. And then I can do this. Null, -1, -1. Okay. So we do ws dot, and then instead of this, I need to pass in address of ws dot, address of ws dot. Right. And then here, ws dot, ws dot. Yeah, and I need to. So basically, all I'm doing is I'm just moving inside the word search struct so I can just pass it around a little bit easier. Like halfway through this, I realized I could have just probably do that. That's the function I need to override. Kirkar. Right, and then I can go down here, and instead of taking in the car pointer, we're just going to take in word search. We're going to take it by pointer. In fact, I haven't used this yet, but because I haven't needed to, const word search pointer, ws, 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 I times number. And then we're going to do see num calls. Num calls. That's the one I need to allocate, so just gonna give me an error there, num calls. Print word search. We're gonna pass in address ws, and then ws dot, ws dot, ws dot, ws dot. Okay. That should move everything in. And then so I'm gonna call this ws get, and we're taking ws I j. Okay. So we're gonna go down here. car pointer, ws get ws I and then so if I is less than 0 or I is greater than equal to num. Rows or j less than 0 or j greater than or equal to. Just so you have the arrow operator. Yeah, it does. So I can do this. And oh, okay. So this needs to be a dash. So this is how you dereference and access at the same time. So it's equivalent to dereferencing and then doing a dot. That's fine because I'm doing an array. So ws dot numcalls. So if either of those works, then and we're going to return null if that's invalid. Otherwise, we're going to return ws.wordSearch. Let's see. I times ws. Oh, it's 1 plus on both. That's what the error is. Okay. So basically we need to offset by 1 and then we need to offset by another 1. Okay, so instead of this, we're just going to do car pointer car equals ws get attribute ws ij. Let's see if that works. Yes, this is probably gonna get mad at me. It's fine. Go undeclared use in this function. So we go to line 100. We see here that I did this. I need to do that. Print word search needs to be 1. And this needs to be 1. And this multiplication needs to happen here. But I could actually just do this. ws get ws, and then I need to pass in ij. And I need to dereference it. Yes, I need to dereference it. Okay. Let's try that, see if that improves anything. Error-free word search, right? We haven't cleaned that up. ws dot. Too few arguments to print word search. We need to change this up here. So we do struct word search pointer ws. Cool. Request member numcalls is not structure or union. So I don't, that's line 50. I don't know what's going on there. Yeah, no, I just hit tab. Okay, so now if we try make, we're gonna get different errors, and that's pretty cool. Right. Discards const qualifiers. Conflicting types for this. Print word search, print word search. So print word search, we're actually just gonna... Yeah, they're conflicting things down here. I'm just gonna take away the const because I can't maintain this. Returning car from a pointer with makes the pointer from an integer without a cast. That's a pretty good error to catch. So this is line 94. We can see here. Just gonna do this. S make cool, and then we try running it, and there it goes. It works correctly. It prints it out right. It takes care of everything. Cool. Right. Again, gonna check for questions. There are no questions. So again, I'm either doing perfectly or very, very badly. Either way. Right, so then where are we? So I print out the word search, I found the number of rows. Oh yeah, I think I was gonna keep reading the file and seeing if I can get more things. This one's pretty standard. We're just gonna scan F reader. We're going to get the number of letters, or we're gonna get the number of words. If we don't read any, then we're going to yeah, we're just gonna do F puts. Right, so there's actually a smarter way to do this without the go-tos that's a lot better because it automatically handles things like, I was thinking, do I need to go here or do I need to go here, right? And I don't know exactly where to go, so I have to figure that out, but we got that. Got it. Size of car. Right, there's a string duplication function, but we're not gonna use that for now. Okay, so we're gonna need to write another function to free up everything in here. So we're just gonna do void. Actually, you know what? I'm gonna cheat a little bit because I happen to know what's going on here. Because the way I was thinking, you could have an array of arrays, but again, that like freeing and deleting that's always weird. You kind of have to go around, so I'm gonna not do that. Okay, let's see if I ever. Right. So what I'm gonna do is um, so yeah. So we want number of words times max word length plus 1 to add just a little bit of null character in there. And we need to tell it to, since we're doing characters, we're going to do size of character. And then again, whenever we do this, we got to go. And then if it's null, we do clean up words to find free. Words to find. And then you gotta make sure you get the stack right, so this needs to actually be here. So that way, like, we can go here and then free it. And then null, again, we're probably not gonna see these things, but memory errors. Oh yeah, no, I forgot we have to set error codes too. 1. Yeah. We're also gonna do print out an error. Okay. And then here we have to do error code equals 1. Where's the next go to? 1. Okay, so yeah, we've taken care of that. Okay, so we've allocated the character hash, we've cleaned up where it's defined. Yeah, again, anytime you have like 3 parameters in here, it's probably a good idea to wrap it up in a struct, so we're just gonna make another one. Word list. And then we're gonna do default. Word. Null. 0, 0. Okay. So I was worried I wasn't gonna have a lot of functions here. WL. So yeah, let's just okay. And then we're going to do car pointer WL get struct word list pointer WL int n. Okay, so this is just gonna get the nth word. fact, you know what? Let me actually start making more files right now, because it's just getting kind of annoying. So we're gonna make wordlist.h. And then let's just rename you. If I'm gonna use, I forget what it's called. It's the one where you go through. Okay, so you can do this, and every modern compiler accepts it. But if you want to be very pedantic, you do like if def name of project, name of file, h. No, it's if and def. Define and if, and then you type what you want in here. So I'm gonna do it once in here just to show you that. And I'm just gonna take some of these guys. So this is word search.h. We're gonna take this guy and we're gonna put him here. And then we're gonna take this guy and we're gonna put it here, and then we're gonna use a pragma once. Pragma basically just tells the preprocessor, hey, figure something out. It's usually something more complicated than normal. I'm also gonna make, you know, I just need to do this main.c, and we're gonna make okay, so I just need to separate this out. It's just getting too big. So we're gonna take this guy and okay, so general vibe of putting things in headers. You put things in headers if you want them to be seen from multiple places. So in this case, I want this to be seen in multiple places. So this is a way for me to tell the computer that, hey, the compiler that, hey, this is going to be good. Don't worry if you don't see it in this file. It shows up somewhere, so you can just chill. We're going to take this guy, put it in here. I'll leave that for now, but these two guys need to go to, oh, I don't have a word search. Wait, actually, hold on. Let me actually, we're going to take main, and we're going to put it here. Include word search.h, include word list.h, include whatever else was in here. Actually, I'm gonna leave it, and then it's gonna get mad at me, and then I'm gonna go, oh, that's how you fix that. And then word search.c is gonna have these two functions. Wait, hold on. So yeah, no, and then yeah, so I'm gonna do another one, and then this I'm just gonna do H. Sorry, this is just screaming at me to get everything out of the way, because it's just gotten to the point where there's just too much stuff in one place. So yeah, I'm gonna take these locations and I'm just gonna cut them. New file. Let's see, we're gonna put these here. Cool. We're gonna include locations.h. We're gonna go here. Word search dot. registry.h doesn't need to exist anymore. So this needs stdio. This doesn't do any mallocs. C-type. What did C-type do? I know this says that. Fine, let's save all. Okay, and then, let's see, locations. I need to go to here? Nah. I need to go here, and basically, these two guys need to go here. Okay, so now, because I've changed the files that were there, I need to go back into here, and I need to actually edit this, because right now I'm just compiling one file, so technically, to be pedantically correct, I would need to type in every file over here. But there's a trick here that I can use. It's this. This command, basically. This is gonna basically get everything in the source dir, right? Anything in the C file, it's gonna store it in sources, so then I can just do you see sources. So I can do this. Then I go to terminal, go to R, CMake, we're doing debug, we're gonna do make, it's gonna give me a lot of errors. Include standard lib.h or provide a definition for free, so we go to locations.c. Implicit function definition. Null undeclared here, not in a function. Oh, I need to include. See, this tells you. So null undeclared here is defined in the header std_def.h. So I need to go here. This, and now if I compile it, it's gonna compile that one properly, but it's gonna mess up other ones. Main null undeclared here. So I go to main because main has a lot of printing. So I'm going to include stdio.h, see if that fixes all of them. If not, numwords. So it's getting mad at us because I need to do wl.numwords. Okay, cool. And then max word length. This car pointer thing here needs to go. S, okay, I can go make again. Null undeclared here. No. std_def.h. I'm in main.c. Oh. That's interesting. Oh, okay. So this is what's messing with me. It's in wordsearch.h. So I need to include stdef in wordsearch.h. And then in main, I can take it out. So now another one. Words define isn't defined. fputs needs to print out the error. Okay, so that's line 61. Error, cool. And then I need to do a WL. Make. What does word list have? Word list. Yeah, that figures. Okay. That should fix more of them. I don't know why it's words list. That's the thing I hate about autocorrect. Okay, fine. There. So now it was able to compile main, word list, word search got mad in use of undefined type struct. So in the word search file, undefined type means I didn't include the file that I needed, so I didn't include I did not include this file, so it doesn't know what the hell a word search is. So I go up here, I make multiple definition of default location, first defined here, multiple definition of this, first defined here. So yeah, it's freaking out because it sees this in two different places, and it's thinking, wait, which one do I use? Because I defined it in multiple places. So, that's not too hard to fix. Okay, so const means it's constant, so you can't change it because it's a default. Inline means that don't worry if you see in multiple places. Struct locations means that we're doing struct locations, and this just sets list to be null, size to be 0, and back to be null. Okay. So that should fix part of it. Default location and then default word search, same thing. Okay, what inline really means is don't get weird if you see in multiple compilation places. So you could see here, blah blah blah, main.c, locations.h, multiple definition of default location, and then it's also defined in locations. So it's defined in main and locations both, and it's freaking out because it doesn't know which one to pick, or anything like that. But if I say inline, it's going to see multiple definitions and be like, oh, okay, I don't care. So then, if I do make, warning, variable declared inline, warning, variable declared inline, warning. Okay, so we can do xturn. Xturn means that you can share variables across files. Wait. Why is this one fine? Okay. Yeah. Okay. V, cool. And then okay. Let's see if that fixes anything. Cool. Access elements instruct initializer. Where this has, okay. So it's just a weird circular thing. Okay. Okay. So I'm actually gonna do inline. And then I'm just gonna delete you here. And then we're also gonna inline you and see if I can't fix it there. Let's see here. Make. And this is in locations, so I'm gonna try that. Yeah, that gets mad. Oh, hold on. Okay, so I think I figured out. It thinks the default location is the struct. Let me try that, see if that fixes. Hmm. Okay, almost got it. How do you do constant structs? I normally I can just set this. Okay, okay, okay. No, I got it. Yeah, as you can tell, C is not my main language, but it's fine. No, 0, no. Okay, let's try this. Bro, they want to fight. Oh, this is in word search and word list. What? Why does it give me warning variable declared inline? Okay, well, let's say I figured out kind of the main idea. It's equals, and then it's gonna get mad at me for something else, but that's something I can live with. So save here, save here. How is it? So wordlist dots. Oh, yeah, no. I was including the C file instead of the header file. And then I got to go to default word list. Include std_def.h. Warning. Error redefinition. Man, this will give me the business. Let's try removing the const, see what happens. Actually, hold on, where's default word search being set here? I'm not even using default word search. Okay, well, I can get rid of at least part of the problem if I just delete that. And then word list, I can delete that too. Multiple definition of default location. Okay, and I can do, hold on. Try this. Null, 0, null. It's fine. Inline might be a C thing. Multiple definition of default locations. How though? This might. Yeah, okay. So because header files are pasted in, if I add the static, it means that this default location exists completely separate from any other default location, right? So this default location in here that gets included is completely different from the default location used here, but it's not. So static was the one. Anyway, Control R, oh, sorry. Control R, /word search, free invalid pointer, that's cool. Again, we're gonna do okay. So let's find out what this error is. gdb-args, we're gonna run. Where did we free the invalid pointer? Oh, that doesn't, oh, sorry, BT. Frame 6, free wl.wordList. Info locals. So all the backs are set to 0, which is actually bad. Character hash. Wordlist was never set. So yeah, it's getting mad at us because if you look at main, we never actually set this. So we actually need to go up here. Where the hell is word list? Main. We're gonna do this. So this should help block out some of the errors, and then we can go to word list.h. Static const struct word list word list equals null 0 0. That's cool. We can go here. Let's make undefined as reported once for each default word search. Okay, and I took out default word search, but that's fine. Static construct word search, default word search equals null 0 0. Okay. So that should be fine. Make redefinition? How the hell do I redefine it? Okay. It's fine. There. And then it should work without any errors because could not allocate words to find. That's cool, probably because we didn't, yeah. That's fine because, once again, we didn't set it to anything. So now we gotta go to wordlist.c, wordlist.h. So we gotta do, we're gonna do void wl allocate struct int max word length int num words. Cool. Pass this in. We go here into this file. We actually implement it. Okay, and then we do first off wl. Normally I kind of shorten these so they don't like overlap, or you could normally do like an underscore in front sometimes. Num words equals num. This is just so like the types don't overlap because this is basically a constructor. I'm just gonna do NWL. And this is only in the actual code, so I don't do in declarations. MWL NW. Oh yeah, I need to, well, what's the type here? Word list. Yeah, let's actually calloc because we do need a calloc. So we do max word length plus 1 times num words size of car. Okay. And then the null's handled somewhere else. Okay. So now we freed word list, free that. If we make error, right, because we changed the name, so MWL NW. Cool. So we go back up, we make use of implicit function, so we need to include std_lib.h, make, there we go. Okay, so now if we do the, I'm hitting Control R and then typing in characters and it finds the most recent version. If we do this, could not allocate words to find, because we still aren't calling WL allocate. We also aren't calling, we also haven't implemented WL get. Struct pointer WL in max word length Right. Okay. So I think that should be good there. And then we need to basically just call WL allocate address of WL, and then we need to pass in, oh, it already has num words. I'm actually just gonna take these out because I think setting them earlier makes more sense. Okay, so it should allocate the word list. I started at 7. I'm gonna finish at 11. Okay, so now if I save, I make MW. Oh yeah, I don't need these anymore. And then I can do WL dash max word length times WL dash num words. Cool. Now I can make, and that works. Control R dot slash. It runs perfectly fine. Okay, so I've allocated everything. I have all the word list stuff. Now we can move forward. Yeah, I basically just kind of moved around and did like 2 things, so. Okay. Let's see here. Okay, there's got to be a C function that. No, this is the gross one. Why are all the gross ones up here? C++.com is the best one, but there's also another one that's great, CPP reference. So yeah, I could do fgets, never use gets. I can get it from a file, which I'm currently reading from, and I can specify numbers. So it'll keep reading. Let's see. Yeah, sorry, I'm just thinking. Okay. So now what I can do is for int I, or, well, I have to do it later. For int I, because I need to loop through this, I less than WL dot num words, I plus plus. F gets, I need to specify the destination string, so that would be WL get WL I, make sure this works, yes. and then I need to specify the number of characters next, which is going to be wl dot max word length. And then we can do reader. So this will do weird stuff if you have longer words, but it should be fine. And I'll keep this as that. And then we also need to set the last character. Let's see. I'm going to see. I wonder if there's a. I wonder if this is standard, so that's what I'm looking at. Ah, that looks like a. Wait, is that standard C? Huh. Because the gross way to do it would just be to loop through the beginning until you reach the end and then just done. Okay. Okay. I think I can use this. So yeah, we're gonna include string.h just to get this function, and then when we get that, we're going to wl get wli. strcspn. Let's see, I wonder what this guy does. Okay. Let's try that. And we can tell if it works. Okay. Almost done with this. Let's see if this works. Okay. Make too few arguments to f puts because. Okay, let's try that. In compute type, so we need to get the address of this. Get the, let's just do this. This should also be a little bit easier to read for you guys, so, or just in general, because you could look at it and go, oh, that's the current word, not wl get wli. Okay. Okay, controller dot slash. Okay, so almost works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's actually switch this up to printf. And we can do this. So this will allow me to see like where it is. Because programming is blank and it shouldn't be. Yeah, so it's including a new line in there in 2 different places. So it's skipping these last 2. So the first thing I need to do is actually, if I expect it to be on a new line, I just need to like fget something. Okay, so first off, I need to do okay. So this will just get rid of the new line that shows up here after the 17. I need to make sure that okay. So that should solve one of the problems because that's just gonna be there. Make what is it now? And then I'm just storing in the first word here because I just happen to have a character buffer, but I'm gonna get rid of it. It's gonna get overwritten immediately. Okay, so now after programming, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So programming is a little too long. So when we allocate this, I need to actually okay, so I'm just going to increment this by 1, so it's, or actually, let's just add 2. So that way it's always guaranteed to be like a little bit longer than it needs to be. Okay. So yeah, now it's got all the words. So you can see it prints out all the words, it prints out that we have everything in memory. And we got 15 minutes left. I'm going to look for questions. Let's see, no questions in ACM, no questions ACM. We're going to check the Discord. No questions. And we're going to check the YouTube chat. No questions. Okay, so it looks like we don't have any questions. Getting in memory is pretty good. I think making sure I deallocate this. I cover this. I have all the character hashes. I'm also going to get rid of this because I don't need this anymore. Yeah, and I think because of the way I structured this, I don't actually need to over allocate these guys. Anyway, locations, got the character hashes, this is all allocated properly. I might call free character hashes in here. Yeah, this would probably be better if I called it in here. And then this would reduce a little bit of complexity in my main method because I don't need to go here. So it cleans up after itself. Okay, so we got that. Print out the words. Okay. Yeah, I think the next step is we basically have everything except for... Oh yeah, so this might be an issue if I do this. So if I have more words than I say I do. Right, so it's actually just not going to set the memory because it doesn't reach that high. And it allocates memory, but it's not going to get anything, so we can go back to 17. So we got it completely in memory. Too shabby, and this is just, by the way, you could be a lot lazier with errors and stuff like that and probably get a lot less done. So anyway. So yeah, now, okay, get the word list. Yeah, so I'm gonna add a WS get, and then and it's gonna be the same as int I j, and if less than 0 or I is greater than or equal to WS num rows plus 2, or j is less than 0, or j is greater than or equal to WS calls plus 2, and I gotta be careful here to make sure that I'm containing this in here because, you know, operator overloads can get a little weird. So I got that. If it's outside the range, we just return null. Otherwise, we return word search plus I times WS numcalls plus J. Okay, so this is what we're going to use for actually checking stuff, and then we're going to use WS_get for the other one. Right. So let's see. Okay, and then last thing I think I'm going to do, copy this, put this in word search.h. And so the difference between this one will only get you valid characters, this one will get you the buffer. And we're going to use the buffer for just checking stuff. So yeah. Okay, and then in main, so the idea is, what I'm going to do is I'm going to actually delete, or was it? No, what I'm going to do is I'm going to print out the results, but I'm going to be like, everything else is going to be replaced with a dot, right? So it's not going to print out the whole thing, it's just going to print out a dot. So, right. So, let me see if I can't do a mem set. Void int c character. Okay. See a little drawing there. Anyway. Okay. We're going to do another one, struct word search. Found WS. Do I have a function for this? No, just print. And I can set default, but null ws dot num rows, ws dot num calls. Yeah, okay. So then what we're going to do, and we're going to need another one, so okay, so here we go. Found ws dot word search equals malloc. We're gonna do a malloc this time, and we're gonna do size of car times ws num rows times ws num calls, right? And then if found ws dot word search is null, then we're just going to f puts could not allocate std error. Oh, and I forgot, this will clean up after itself, but it should go to clean up words to find. Okay, and this should go to clean up found ws. Freeing null won't do anything, so technically this should also go to free words, clean up words to find. We'll do it. Because again, if word search is null, it hasn't been allocated, so we don't need to worry about allocating it. Okay. And then we can also do a memset, which sets the memory. You pass in a pointer, you pass in a character, and then you pass in num. Note that we didn't do calloc because we're going to set it to something else. Okay, so we pass in found ws.word search, because this is the standard, and then we're going to give it the character. We want something really small so you can look at it and go, oh, okay, that's obviously not there. So something like an asterisk would be fine. I like the period because it's so small. It's like, oh, there's clearly something there, but it's not something that you should be looking at. Or we can even do an underscore. I think underscore might be good. And then okay. So this should set all this, and it should be good. So we set this, it does underscores for that. Hold on. I'm thinking about it, and I might need to calloc it again. No, because if I do, wordless will be fine. Because if I do ws get raw, it should work properly when I print it out. No, because this is, I need like this check, and then I need to do this, but without the +1s. Okay. Now we gotta think of a good name. Search pointer ws int I int j, and then I need this guy up here. And then I need this guy here. Okay, so not necessarily the best name, but it'll get you through it. Yeah, man, I wish this could be more exciting. Okay, we can save this, main. And that's fine. Okay, so now I'm just going to do a quick print here of the word search to make sure that it's printing out what we think it does. Print word search already does stuff, that's cool. Print word search? Yeah, because I'm using WSGet. And I could be smarter about this. Because I could pass in a function pointer, but and then like tell it to use this kind of get. I'm gonna move these guys up here. Because this is a lot of copy pasting code, and that's iffy. You know, you should know how I feel about copy pasting code. Okay, so we're gonna print no border word search. And then no border word search should be using this function instead. Okay, so let's try and make, see what happens. Expected struct this, but argument is a type. Oh, that one's a classic. We passed in the value instead of the pointer to the value, which, there we go. And then we can do this again. Then we could do try.slash, run it. And as you can see, it prints out a bunch of like single lines because that's what he filled it up with. So we've got everything here. The only thing we would need to do is loop through, start from everything we found in the word list. So if you remember WL has basically, WL has all the words, and then we should have locations. Character hash has all the locations, right? Let me think. Let me be a little bit smarter about this. Okay, so int I and j. We can do so this creates a list of coordinates. This is going to point to wherever we currently are in the list. Okay, so we go to allocate here. Actually, nah, well, crap. So we're gonna go size of int. And yeah, nah, I'm just gonna keep it as an int because I can. I don't need to be smart about this. Okay, so the location can store the where we are in the int, or where we are in the word search. So that'll be fine. Let's make a. Yeah, I think it might be time to call it for now, and then I'll try to see if I can't do something tomorrow. Yeah. Well, to anyone watching, hope you had a good time. Hope you learned something. I think a 3 hour stream is probably a lot. But yeah, you can probably watch on your own time. I always thought I'd get more done, but I kind of didn't. So I had to kind of deal with that. Wait, that was 4 hours? I thought it was just 3 hours. Oh, dang. I got here for a while. Anyway.